Now, precision is a term that's used to describe how close two or more measurements are to each other. And oftentimes we use this bullseye to illustrate it, and it helps us understand it. So, if you look at this bullseye over here to the left, you'll see that it shows that there are 7 darts that hit it, and the objective is to try and hit them right in the center, the bullseye. But one thing you notice is that of all these 7, only one of them hits the center of the bullseye. So we say these are not very accurate shots. Another thing you notice is that they're not close together either. So because they're not close together, we can describe that as being non-precise. So one shot was accurate, the other ones were not. So there's a lot of inaccurate measurements, or a lot of inaccurate hits to the bullseye. Only one made to the center, but also our precision is very low as well because we have them all spread out. Contrast that with this one here. This shows that you have all of the shots really close together. That's a high precision. However, because they were not close to the bullseye, those are inaccurate shots. And then over here, go to this left one, these were much closer to the bullseye, so they had a much higher degree of accuracy, but the precision wasn't really great. So the precision was fairly low, but the accuracy was higher. Now we get to this one, the lower right hand one. This bullseye shows that all the shots are very close to the very center. So we had both a high accuracy and a high precision. So really, the precision depends a great deal on the procedure that we use to make a measurement. So if you're not using the instrument the way it's designed to be used, your precision is not going to be very good. It'll probably affect the accuracy as well, but it's definitely, you're not going to have very good precision. So for instance, we know if we use a graduated cylinder, and this is the meniscus, you're supposed to, when you use it properly, look at it at the same level as that meniscus. However, if you have more than one measurement, and someone measures it this way, but then another person comes by and they look from the top down, and then you have another person that makes a measurement, and they look from the bottom up, they're all going to get different measurements. So the procedure is to actually look at this at the same eye level as the meniscus. So if everybody did it that way, your numbers would be very much closer. Your precision would be much better. The instrument itself has a certain degree of accuracy that's not really, in this case, affected by the person using it, but the precision really is. So we know the accuracy of this instrument. So if this is a graduated cylinder, and we use the accuracy that we saw in the first one, let's say plus or minus 0.5 milliliters, this would be a measure of how accurate this graduated cylinder is. How we use it, right, if we're using it properly, that's going to affect the precision. Now this next page, I'm asking you on here to answer these questions. So try to answer these questions with what we had talked about. Now this one down here, you're looking at these instruments, and they're all used to measure volume. One thing you should know is that the volumetric flask, it only has one measurement over here. So this will measure a certain volume if you bring it up here. So if you make measurements over here, give liquid over here, you really don't know exactly what it is. You have to guess. Where the graduated cylinder, they have many more divisions. Okay, and then if you look at a syringe, because it measures very, very small volumes, this is going to have a very, very small increments. And generally speaking, the more divisions you have in an instrument for making measurements, the more accuracy it has. Sorry, not accuracy, more precision it has. Why is that? Let's look at an example. If I have these two pieces of instrument that I'm measuring a volume. If I have a volume over here like this, right, up to this level, I put that same volume in here, probably it's going to go here. It's going to be, I'm going to have to guess what that volume is, because my graduations, my divisions, if you will, they don't go up to the amount that I'm actually measuring. But over here, because the volume is up here and I can actually see one of the divisions of it, I can tell what the volume is fairly easily. So if two more people use this instrument to make a measurement, this one here, they're probably not going to come out very close to each other. But over here, the two people are probably going to come up with the same measurement. Why? Because that division is right there to help them, guide them as to what that volume is. So if you look over here, of the three of these, this one's going to have the smallest division. Now the pipette, this one, it only has one measurement that tells you what the volume is as well. This over here has a lot more. Now, one thing that, and I'll talk about this later, the graduate cylinder and the pipette, they measure the volume of liquids you add to them, where the syringe and the pipette and the burette, these all measure volumes of liquids that are leaving them. And that's why if you look at the numbers, they're opposite. Over here you have 0 over here. Over here you have 0. Why? Because over here, as liquids are moving down, the volume is going to increase because you're measuring how much liquid is leaving. Here, you're measuring how much liquid is being put into it. So as you go up, the volume is going to increase. All right, so keep that in mind. Now this page is just going into interpreting the divisions of any instrument we're using. So this is just showing a ruler. But the same concept would also be true if you're using a graduated cylinder or a burette. When you're making a measurement, what you need to do is figure out the value of these lines. So if I look between 8 and 9, right, there are these divisions or graduations that I have in here. So I want to find the value of these. How do I do that? The way I do that is I got to count them, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions here. So I have one, let's say this is a centimeter. From here to here, we'll say is 1 centimeter. There are 10 divisions of it. So each one of these is 1/10 of a centimeter over 1 over 10. So if I have a measurement, let's say here, I go from here to here, right? There's 1, 2, 3, 4, 5. 5 divisions, or it's 5 over 10, or half a centimeter in this case. So that's what this is all we're talking about here, is looking at the value of these divisions and how we figure out the value of those divisions. So here, what I'm asking you is just tell me the value of that division. On this page, all I want you to do is tell me, if you look at this here, tell me the measurement up to this point. And then A, if I have a measurement over here, tell me what it is. Now, when I have a measurement, let's say I have a ruler here. So this is 0, 1, 2, and then I'm going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 divisions here. 2, 3, 4, 5, 6, 7, 8, 9, 10. They're not even, but just pretend they are. Now, a lot of times when we measure things, they don't end up right on one of the lines. So for instance, if I have an object like this, and I wanted to measure that. So I know, let's say this is a centimeter, right? 2 centimeters. Each one of these divisions here is going to be equal to 1 over 10. In other words, they're 1/10 of a centimeter, or 0.1. So if I want to measure this object here, right, it's zero point 0.1, zero point 0.2, zero point 0.3, zero point 0.4, 0.5, 0.6. Right, so I know it's zero point 0.6. But now I got a problem here. It goes between the zero point 0.6 and the zero point 0.7, so it's halfway, or about, right? So I'm gonna say that that's about halfway, and we're estimating this because I don't know precisely. And if two or more people make this measurement, they're probably going to come up with a little bit. They may come up with slightly different than me. They may come up with zero point 0.6 or zero point 0.4. So this last number here, that number I'm actually estimating. So anytime you take a measurement, the last number that you have in there, the smallest digit, if you will, that number is one that we've estimated. So up here for this ABC over here, you may have to estimate when you're making those measurements. So try the best you can on it. These over here, you want to try these two, and you might have to also make estimates on there. On this page, I'm just asking you to tell me the value of B. And then down here, I want you to describe what a meniscus is. And that's something that if you need to, you can do a search on it. But this is showing you what the meniscus is in this drawing here. So you could use it, just describe what that actually looks like. All right, this page is actually going into measurements using either a pipette or a burette. Because remember, we said that a, uh, a pipette or burette is actually measuring liquids that are leaving the container. So I have two examples over here. And what I have over here, this diagram, I'm showing you the difference between the two, the numbers going in both directions. So if you look here, when you see the zero up near the top, that's going to indicate that it's measuring liquids that are leaving the container. So if I have numbers that go from 0 down to 6, it's actually going to measure this liquid going in to a container. So when the liquid, I have the meniscus here, if it goes down here, that means 1 milliliter of water has left this burette, let's say, and gone into this container. However, if you look on this side, I have 0 down here, 1, 2, 3, 4, 5, 6. That would be measuring if I put liquid in here, I add liquid, it's going to go up like this. So if it's this point, I've added 2 milliliters of liquid, 3 milliliters, 4, 5, 6. So that's why you see the numbers on both sides. So if I've illustrated that here a little bit more, is that you have, let's say this is a burette. I'm showing the liquid leaving the burette, and as the liquid in here goes up, here the volume of liquid goes up, the volume of liquid is going to go down in here. So if I go from this one here over to this one here, you can see that more liquid has left this. So I've gone from 0, 0, 1, 2, 3, so about 3 milliliters has left it. Those 3 milliliters have gone into here. So I've measured the liquid as it's going out. So this is just asking you, just try to answer these questions as like at the increments. We've gone over that. And the scale. Okay? And for these, you just want to tell me the volume that it's showing. And if you notice the zeros down here, the numbers are going up this way. And here, the value is going, that we're further up the graduated cylinder. So it's going up. So this is measuring something that what liquids are being added to. For these two, you just want to tell me the volume that they're showing on them. And again, these two here, you want to tell me the volume that they're in those graduated cylinders. And then this last one here, this is measuring temperature. So if you look on the temperature, so these are thermometers. When we read thermometers, a lot of times you'll see that there's negative numbers and positive numbers on it. So in, let's say, Fahrenheit or Celsius, you can have temperatures that are below zero or above zero. So what I did down here is I'm showing you both scales. So I have zero here, and if the temperature is less than zero, you can have negative numbers. That's all it's showing over here. So if I have a temperature that goes up to here, it's about -1, let's say it was Celsius. Okay? If it was here, it would be 0 degrees Celsius. If it was here, it'd be 1 degree Celsius, and so on and so forth. That's all we're asking over here, is that you have -30, -40. So somewhere up here is going to be 0 degrees Celsius. And again, over here on the top, these numbers are just in positive numbers. So I'm going to report my values as positive, where these over here, because they're negative, this number here, that temperature is going to be negative. And if you notice, it's in between those two increments. So you're going to have to figure out what that actual value is. So you have to estimate it. All right, on this page, again, I want you to tell me the volume of the meniscus. Now, this one, it could be a little tricky. I'll give you a hint. If you notice on this one, and this one, it goes from this one's showing a higher number here and a lower one here, right? But over here, if you look, there's a lower number here and a higher number here. And this one, you have a higher number here and a lower number here. So they seem to be going in different directions. So look at the directions, and so some of these are measuring liquids that are being added, and some of these are measuring liquids that are being lost or emptied out of it. And on this page, I just want you to make these measurements, and then so determine the length on here, and over here, just do the temperatures. So print these up. You want to fill them out, and then submit them, preferably as a PDF, a picture if you have to. And so make sure you submit that through Blackboard, and then you get credit for it. And then we'll go over this in class. All right, thank you.